Hi guys, நான் உங்கள் திவா. Today we seen about drop weight test and other large scale test. Today first we seen about generally. Probably the chief deficiency of the CHARP impact test is that the small specimen is not always a realistic model of the actual situation. Not only does the small specimen lead to considerable scatter, but a specimen with a thickness of 10 mm cannot provide the same constraints as we would found in a structure with much greater thickness. The situation that can be result in at the particular service temperature, the standard Charpy specimen shows a high self energy, while actually the same material in a thickness section structure has a low toughness at the same temperature. The most logical approach to this problem is development of tests and that are capable for handling specimen at least 25 mm thick. The development of such tests and the relational methods of analysis has been chiefly the work of Pelinin Inverse and his co-workers at the US Naval Research Laboratory. The basic need for large specimens resulted from the inability to produce fracture in small laboratory specimens at stresses below the gross yield stress, whereas brittle fractures in ship structures occurs at service temperature at elastic stress levels. The first development was the explosion cracks tester, which featured a short, brittle well bead deposited on the surface of a 350 into 350 into 25 mm steel plate. The plate was placed over a circular die and dynamically loaded with an explosive charge. The brittle well bead introduces a small neutral crack in the test plate. Similar to a well deflect crack, tests are carried out over a range of temperature and the appearance of the fracture determines the various transition temperature. Below the entity, the fracture is flat, elastic fracture running completely to the edges of the test plates. Above the nil ductility temperature, a plastic bulbous form in the center of the plate, but the fracture is still a flat elastic fracture out to the plate edge. At still higher temperature, the fracture elastic does not propagate outside to the bulged region. The temperature at which elastic fractures no longer propagates to the edge of the plate is called fracture propagation elastic. Note this point. The FT marks the highest temperature of fracture propagation by purely elastic stresses. At yet higher temperature, the extensive plasticity results in helmet type bulges. The temperature above which this fully ductile tearing occurs is the fracture transition plastic FTP. The drop weight test DWT was developed specifically for the determination of entity on full thickness plates. A short bead of brittle well metal is deposited on the surface of a plate, typically 90 into 350 into 15 to 25 mm thick. A small is introduced in the weld bead and the specimen supported as a simple beam in a constant temperature bath. The brittle weld bead is fractured at a near yield stress level as a result of dynamic loading. From a falling fracture at a near yield stress levels results in dynamic loading from a falling weight. The unwheel stop restricts the deflection of the test specimen since the specimen is wide beam loaded in the 3-point bending. Now we go into the topic drop weight test DWT and the large scale fracture test based on explosion crack starter test and entity determination. Now we move to the next slide. Limitation of sharping impact text. We must know that small specimen may not represent real structural behaviors. High scatterance result. This scattering is mostly results in high, not in on low. Cannot stimulate constants of thick section. At service temperature, thick structure may show large toughness. even if Charpy shows high self energy. Next slide. Need for large scale testing. Specimen is greater than 25 mm thick required. Developed to stimulate the real structural condition work LED by Pellins and US Naval Research Laboratory. Brittle fracture in structures can occur below cross yield stress. The next slide. It is the diagram of this explosion crack starter test. Now we see the first diagram, flat fracture. In this, the cracks fractures are not dependent. It is a NDT structure. Next, this bulge or fractures. In this, a small circle is placed inside the structure, and a fracture is fully loaded in the side of the part. Next, the bulge is partially fractured. Third one is bulge and shear stress. Now the structure is now the fracture is placed inside the part of this. It is dependent of temperature. This is called the explosion crack starter test. Next, we move on to the explosion crack starter test. Then we find Next, we move on to explosion crack starter test. It is finally lastly seen about that 350 mm, 350 into 350 into 225 mm steel plate. It is made up of short brittle well bead deposited on surface. Plate placed over a circular die and dynamically loaded using an explosive charge. This explosive charges may be anything used in the laboratory. Well beat introduces a small neutral crack. Next slide. This is about the fracture behavior versus the temperature. Below NDT, flat elastic fracture to plate edges. Above NDT, plastic bulges forms but fracture still elastic. It's not as plastic from FTE. Higher temperature, whereas elastic fracture reached edge. FTP, temperature above which fully ductile tearing occurs. No brittle tearing is occur in this FTP. High temperature, high temperature. Next we seen about high temperature helmet type plastic bulges. Okay. The next slide we go into, it is drop weight test. Here the surface is placed in the specimen is placed at bottom of the weight, we falling in the top of the specimen. The crack bead is placed in the bottom of the specimen, and the uneven stop is placed at the be placed below the cracked weld bead. This is the general structure of this drop weight test. Next, we seen deeply about the drop weight test. Developed for drop weight test, mainly developed for determining NDT in full thickness plates. Plate size is approximately 90 into 350 into 115 to 25 mm. Brittle well bead with small notches. The specimen is mainly supported as a simple beam, loaded dynamically but falling weight. Uneven stop restricts the deflection of the drop weight test. Next, we move on to the topic of purpose of drop weight tests. The made drop weight test is mainly used for many purposes that are determines a nil ductility transition in a NDT temperature. Yeah. Identifies the brittle to ductile transition behavior. It mainly useful for brittle to ductile transition. Stimulates real structural stress conditions. Evaluates fracture propagation characteristics. This is designed generally about the purpose of drop weight. Thank you. But we seen generally about this finally. The drop weight test DWT was developed specifically for determination of NDT on full scale thickness. A short bead of brittle weld metal is deposited on the surface of a plate, typically 90 into 350 into 15 into 25 mm thick. A small notch is introduced in the well bead, and the specimen supported as a simple beam in a constant beam bathroom temperature. A brittle well bead is fractured at near a yield stress levels as a result of dynamic loading from a falling weight. The uneven stop restricts the deflection of the test specimen. Since the specimen is wide beam, load